Hey there, do you want to finally understand binary numbers? Do you want to know how to represent any number in this system, understand the logic behind it, and even learn some mind-blowing facts? Well, you're in the right place. Stick with me after the intro. I promise this will be the most amazing content about binary numbers you've ever seen. I'm João Sarubbi, PhD in computer science and a professor of discrete mathematics. Why should we learn binary numbers? Here's the deal. All modern computers, from the simplest to the most advanced, run on this system. Binary is the foundation of digital electronics because electronic devices work with signals that have only two states, 0 or 1. These are called bits. The system we use every day is called decimal because it has 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's also positional. But what does that mean? Imagine the number 583. 3 is the units, 8 is the tens, 5 is the hundreds. So 583 is 5 hundreds plus 8 tens plus 3 units. We can also write it using powers of 10. 5 times 10 squared, 8 times 10 to the first power, 3 times 10 to the power of 0. Remember, any number raised to the power of 0 is 1. Now let's talk binary. Binary works similarly to decimal, but with one difference. Decimal has 10 digits. Binary has 2, 0 and 1. Decimal positions represent powers. But in binary, positions represent powers of 2. So instead of 1, 10, 100, 1000, binary has 1, 2, 4, 8, 16, 32, 64, and so on. Even with only 2 digits, we can represent all numbers. Let's see how. Example: the binary number 1, 0, 0, 1, 0. The first 1 is in the 5th position. 1 times 2 to the power of 4 equals 16. The second one is in the 2nd position. 1 times 2 to the first power equals 2. Now, let's add them together. 16 plus 2 equals 18. So, 1, 0, 0, 1, 0 in binary equals 18 in decimal. And the zeros, they don't count because any number times 0 is 0. Another example, 1, 1, 1, 0, 1, 1, 1, and 0. From right to left, 0 times 2 to the power of 0 equals 0. 1 times 2 to the first power equals 2. 1 times 2 to the second power equals 4. 1 times 2 to the third power equals 8. 0 times 2 to the fourth power equals 0. 1 times 2 to the fifth power equals 32. 1 times 2 to the sixth power equals 64. 1 times 2 to the seventh power equals 128. Add them. 128 plus 64 plus 32 plus 8 plus 4 plus 2 equals 238. So 11101110 in binary equals 238 in decimal. If you're enjoying this video, if you're learning about binary numbers, don't forget to like the video, subscribe to the channel, and turn on the notification bell so you won't miss any new content. Converting decimal to binary. There are 2 main ways. First method, successive division by 2. You divide the number by 2, keep track of the remainders until the result is 1. Then you read the remainders backwards. That's your binary number. Example, 25. 25 divided by 2 equals 12. Remainder 1. 12 divided by 2 equals 6. Remainder 0. 6 divided by 2 equals 3. Remainder 0. 3 divided by 2 equals 1, remainder 1. Now, read backwards. So, the number 25 in the decimal system is written as 11001 in the binary system. Quite straightforward, isn't it? The second method is called successive subtraction. Here's how it works. Compare the number with powers of 2 from the largest to the smallest. If the power fits, you put 1. If it doesn't, you put 0. Let's try with an example. 18. The largest power of 2 less than or equal to 18 is 16. So we put 1. Now 18 minus 16 equals 2. The next powers are 8, 0. Because 8 is bigger than 2. And 4, 0. Because 4 is bigger than 2. Then we reach 2. That fits, so we put 1. Finally, the remaining value is 0. So the last position is 0. And here's the result, 1, 0, 0, 1, 0. Cool facts. A byte equals 8 bits, which means 256 combinations. That's from 0 all the way up to 255. And here's something really fun. Computers absolutely love powers of 2. That's why you keep seeing numbers like 128, 256, 512, 1024, especially in memory and storage. Now, 2 very practical tips for you. To multiply a binary number by 2, just add a 0 at the end. It's exactly like in decimal. When you multiply by 10, you just add a 0. And here's a trick you'll never forget. If a binary number ends with 1, it's odd. But if it ends with 0, it's even. Let's recap. The decimal system is positional. That means the value of each digit depends on its position. And the powers involved are powers of 10. The binary system works the same way. It is also positional. But here, instead of powers of 10, we use powers of 2. To convert from binary to decimal, we add up the powers of 2 that correspond to the ones. To convert from decimal to binary, we can use either the division method or the successive subtraction method. And we also saw some fun facts, like how a byte is made of 8 bits, how multiplying by 2 is as simple as adding a 0 at the end, and how the last digit tells us immediately if the number is even or odd. And that's it. Now you truly understand binary numbers and why they are so essential in technology. But wait, our journey doesn't stop here. In the next video, we're diving into propositional logic. We'll start with a simple but powerful question. What exactly is a proposition?